Hi, this is Lalit Vasist and you are watching Engineering Made Easy. In this video lecture, we will discuss the complete derivation of star delta transformations formulas. Okay, so it is possible to substitute a star connected system of impedances for a delta system and vice versa if proper values are given to the substituted impedances. So let's discuss how we can interconvert them. Okay, how we can convert this star connected network into a delta connected network and vice versa, and delta into star. It is also known as, because of its shape, star connected network is also known as Y network. Okay, so let's see the derivations. So the derivation of star delta transformation formulas. So you can see in the star connection between terminals 1 and 2, the impedance is Z1 plus Z2. See this figure, look at this figure. Here you see that if we take these two terminals, terminal 1 and terminal 2, between these two terminals, the equivalent impedance between these two terminals is Z1 plus Z2. The flow of current will be in this direction. There will be no current in this Z3. So current flow is in this direction. So the net impedance between these two terminals is Z1 plus Z2. So this is the equivalent resistance impedance between Z1 Z2 between 1 and 2 terminals. And if you see the equivalent impedance between terminals, same terminals 1 and 2 in this delta connection, how the current will flow in this case? So if terminal 1 is at higher potential and 2 at lower, then the current will divide at this point, and some part will go in this direction and some part of current will go in this direction, in this way, from 1 to 2. So these are in series and this is in parallel to this connection. So it will be Z12, okay, in parallel with Z31 plus Z23. But this equivalent resistance and this equivalent resistance are between with respect to terminals 1 and 2, so they must be same. So let's see. So as we discussed that Z1 plus Z2 is the equivalent resistance between terminal 1 and 2 in a star connection, and this one is Z12 in parallel with this series combination. So this is the equivalent resistance in case of delta network between terminals 1 and 2. So this must be equal to this one. So look at this. This is equal to this. So we write this as equation number 1. In the same way, for terminals 2, 3, between terminals 2 and 3 and between terminals 3 and 1, we can have same kind of equations. Okay, for this one for star side, and this is for delta side. This is for star, this is for delta. So between terminals 2, 3, this is for 2, 3 terminals, and this is for terminals 3 and 1. This is the equivalent resistance in the same way. Okay, now we will see how we can transform a delta connected network, to a star network. Okay, so in this case, the impedance of delta, since we are converting delta to star, so we already know the impedances of delta here. We already know these impedances, and we want to find this, this and this. Okay, so to find Z1, Z2 and Z3 respectively, first of all let's try to find the Z1. How we can find the Z1? We have some equations here. So what we will do, we will subtract equation second from equation 1 and will add it into the result, the equation number 3. Let me show you how. Let's see three equations. Friends, here we have 3 equations, 1, 2 and 3, and I told you we are going to perform 1 minus 2 plus 3. We are doing here equation 1 minus equation 2, and we will add equation number 3 to it. So let's see here, only left side I am showing how we can get a Z1 from this. So Z1 plus Z2, okay, minus equation number 2, only left side we are taking Z2 Z3, okay, negative sign, minus Z2 minus Z3, and add to the equation number 3, that is Z3 plus Z1. See here, so Z2 cancels out, Z3 cancels out, and we have 2Z1. Okay, we have twice of z1. So we can easily, we have only one variable z1 here, so the same action is performed on right side, so we will get the z1 equals to this expression divided by 2. Okay, this 2. So it is very easy. In this way we can easily find it. So we get the z1 here. So z1 is this. We write it as equation number 4. In the same way we can also calculate other parameters like z2 and z3 of the star network, same way. Okay, it's very easy. So in this way we have formulas for z1, z2 and z3. You should keep them in mind. These are the formulas, we have derived them. Now it's time to see the transformation of star to delta. We are going to see the star to delta conversion. So here we are going to convert a star network into a delta network. So we have star, the elements of star network, the impedances of star network already they are known. z1, z2 and z3 are known in this case, and we want to find z12, z23 and z31 of the delta connection. So to derive it, let's suppose another variable known as zs. This zs is equals to z1 z2 plus z2 z3 plus z3 z1. This is zs. Now using equations 4, 5 and 6, 4, 5, 6 are what? These are the values of z1, z2 and z3. Look at this. These are the values of z1, z2, z3 that we have already find out. Okay. So just replace the values of z1, z2 and z3 in this equation. That's it. So we will have the value of zs, just z1 into z2, this is plus, z2 into z3, this expression, this plus, and z3 into z1. Put these values of z1, z2, z3. Since you can observe here that the denominator is same, z12, z23, z31 whole square, which is same in all these three cases. So you can simply add these numerators because the denominator is same. Very easy calculations. So from this you will see that zs comes out to be this expression. So we write it as equation number 7. Now from equation 7 and 4, actually we want to calculate zs. We will manipulate these equations. Okay, how? From equation 7 and equation number 4. What is equation number 4? Equation number 4 is the value of z1. Okay, so from this equation we will use it. This is the value of zs. So we can rewrite it as, using equation 4, zs equals to this part, numerator part is taken same, and we will replace this value which is in denominator by using equation number 4, z12 plus z23 plus z31. This one, z12 plus z23 plus z31 can be written as this, can be written as z12 z31 divided by z1. Okay, so just replace it. It was in denominator, so if you multiply it, it will change. Numerator will go into denominator, so it is z1 by z12 z31. This has been replaced. So just this part cancels out, z12 z31 cancels out, z12 z31 cancels out, and we have zs equals to z1 into z2 3. Okay, you can rewrite it as just z23 equals to zs by z1, z23 equals to zs by z1. Take it to this denominator. Okay, so we have find out this. So zs is what? Zs, we have initially assumed that zs was what? It was z12 plus z23 plus z31. This was our zs that we have assumed. So now we know that replace the zs by this one divided by z1. If you further calculate it, then you will get that this Z23 can be simplified to Z2 plus Z3. Okay, this Z1 cancels out from these parts, so Z2 plus Z3 plus Z2 Z3 by Z1. This is the Z23. So in this way we calculated Z23 of the delta network. Similarly, we can find the Z12 value, okay, and Z31 value also. These are the formulas. So actually you should keep in mind these this was the derivation actually, so you just remember these three forms, how to calculate Z23, Z12 and Z31 to convert a star network into a delta network. Okay, and this initially we have seen these three equations also to calculate the elements of a star or Y network. We also call it as Y network. So these are the three important formulas, Z1, Z2, Z3, to calculate for the delta to star conversion. Okay, and that was for star to delta conversion. So I think you got all these concepts and the derivation. Keep in mind all these formulas, because it is necessary to remember them to solve the equation, to solve the problems. So if you liked my video, click on the like button and share it with your friends, and please subscribe my channel for more videos. Engineering Made Easy. Thanks for watching. Bye. Friends, for more such videos you can subscribe my channel Engineering Made Easy, and please don't forget to like and share the video if you liked it. For more detailed information you can visit my blog. See you soon in the next video. Till then, bye bye.